So acid rain, it increases the acidity of water bodies, specifically lakes and streams. And according to the Environmental Protection Agency in the US, acid rains is the cause of an increased acidity in 75% of all the lakes in the UK. Sorry, in the US. Decreased pH has a specific impact on the aquatic organisms, and for example, at pHs below 5, fish eggs will not hatch, and some species are more susceptible to pH than others, and this is just a table of various animals and the pHs in which they thrive. So at very low pHs, below 5, as you can see, very few species can actually survive in such an acidic conditions. There's an additional problem of very acidic rain, of acid deposition, which is that acidic conditions contribute to the release of aluminium 3+ from the aluminum silicates, that itself is an acidic cation. So you've got the decrease in the pH because of the sulfuric and the nitric acid present, and also the additional lowering of the pH by the liberation of aluminium 3 cations, which are in themselves acidic species. It can contribute, as I mentioned before, to the death of aquatic organisms. It can also degrade soil, for example, forest soil. Very acidic conditions and the liberation of this aluminium cation can provoke a reduction of the available nutrients from the soil. And I would encourage you, those of you that have done soil chemistry in the first year, to look at the concept of cation exchange capacity, and then the ability, the release of aluminium 3+ which is both toxic, is acidic, and it decreases the ability of soil to hold nutrients. Some plants, some microbes, some will not survive in soils with very low pHs. So acid rain or acid deposition does not in general affect humans directly, but the indirect effects on the ecosystems are devastating. Having said that, it is true that both sulfur dioxide and nitrogen oxides have been linked to various health conditions, asthma, bronchitis, and premature death due to heart failure. So indirectly, acid rain does have those effects, because sulfur dioxide and nitrogen oxide have those effects. A way to protect plants and water bodies from the effects of acid rain is by the use, for example, of alkaline compounds, like, for example, limestone, and that increases the alkalinity of the water body, and it improves its buffering capacity, so it is more able to react to that highly acidic conditions. And for plants, another way is adding fertilizers to the soil to try to compensate from the lack of nutrients in soils affected by acid deposition. So in this series of videos, we have been looking at sources and sinks of chemicals. So the sources is the chemical which is released into the atmosphere directly, and they can be primary sources in which the chemical itself is released into the atmosphere, or a secondary source or a secondary pollutant, which is when the chemical is not directly released by an anthropogenic source, but it is produced in the atmosphere as a result of the reaction of primary pollutants. And then we have also looked at sinks, how once a pollutant is released into the atmosphere and a series of reactions happen, how that pollutant is removed from the troposphere and into the land or into the water, or sometimes into another layer of the atmosphere, for example, going to the stratosphere. Although it is true that there are natural sources of nitric acid and sulfuric acid, half of the concentration of sulfuric and nitric acids that are then the precursors of acid deposition are anthropogenic sources. They are related to human activity, fossil fuel combustion, or, for example, in the case of sulfur dioxide, metallurgical processes, a smelting of sulfate-based ores, for example, for mercury or lead, that are typically found in nature as sulfides. There are some dramatic sources of sulfur dioxide in the atmosphere. They are not considered pollution because they're a natural process, and pollution is by definition a man-made. It's a chemical released by a man-made process. But for example, volcanic eruptions can have a huge impact in the level of sulfur dioxide in the atmosphere. And for example, I've got here the example of the eruption of Mount Pinatubo in the early 90s. And that eruption that took place over a few days released more sulfur dioxide in the atmosphere for that year than all the other sulfur dioxide released into the atmosphere in that same year by anthropogenic sources. So yes, there are sometimes a dramatic impact of natural processes into the concentration of those chemicals in the environment. They are not considered pollution because pollution is by definition a man-made effect. It's an anthropogenic source of that particular chemical. So how to control sulfur emissions? Well, this is a way of doing it is by using limestone, calcium carbonate. Heating up calcium carbonate produces calcium oxide and CO2, and calcium oxide can be used to capture sulfur dioxide from an industrial process, for example, an smelting, an smelter, to form calcium sulfate. So and then that limestone can be recovered and clean up and reuse a certain number of times. So this is a way of controlling sulfur dioxide in an industrial setting, for example, a smelter or a power plant. This is the end of the series of videos dedicated to the chemistry of the troposphere. I hope they were useful. As always, if you have any questions, contact me or post in the chat in the discussion boards for the module. And thank you very much for watching.